My name is Esteban Quintero, and I'll be doing the audio microphone. So, sensor stage. So, sound waves are results of disturbance patterns created by energy moving through a medium. So, basically, sound waves are forms of mechanical energy that travel in the form of pressure waves and vibrations. So, this energy moves through a medium, and that could be solid, liquid, or gas. That's why you can hear sounds through walls or any other stuff, because it can travel through mediums. So it doesn't matter if it's a solid wall or not, it can still travel through it. The audible frequency range for sound waves are between 20 hertz and 20,000 hertz. The defining characteristic of a sound wave is its frequency. So as you can see here, you have your lower pitch and higher pitch frequency. All the amplitude controls on your sound wave is basically how loud your sound wave is. So, you know, you have a smaller amplitude, you have a quieter sound, and you have a bigger amplitude, you have a louder sound. So, transducer stage. So, all audio microphones are transducers. The most common form of microphone is the moving coil dynamic microphone, which is the ones pictured here. This is like your typical one that you'll see at like a stage or anything. Like when anyone's speaking to a large audience, this is usually the type of microphone that's used. So transducer stage. So basically the way the audio microphone works is it converts the mechanical energy from sound waves and transforms it into an AC electrical signal. So basically the way this works is you have your coil, you have your diaphragm, and your magnet. So basically your coil and magnet create a magnetic field, and your diaphragm oscillates at the exact same frequency from the sound waves. So here's a picture of your diaphragm, and here's a picture of like the cartridge that has it all together. That's the actual one. So basically the way this works is you have your diaphragm. So when the sound wave enters the diaphragm, it starts to oscillate at the exact same frequency as the sound. So when this diaphragm moves in the positive direction, it disturbs the magnetic field, and it creates a change in magnetic flux that induces a voltage. So when this diaphragm oscillates in the positive direction, it creates a positive AC signal. When it moves in the negative direction, it creates a negative AC signal. So signal conditioning. So the AC electrical signals generated from the transducer are often very weak and unusable. So the way we can increase the signal is through a transformer. So a transformer is basically a magnetic core wrapped in coils, and if a transformer is oriented a very specific way, it can increase the signal. The type of transformer that can do this is called a step-up transformer. So the way a step-up transformer works is basically via Faraday's law, a certain mathematical equation. If you have a transformer that has less coils wrapped around it on the input than the output, then it will increase the signal. So it increases the signal via electromagnetic induction, and basically when the signal passes through these coils, kind of like the transducer, it disrupts the electromagnetic field and induces a voltage. Except in this case, it carries the exact same frequency from the sound wave. All it does is increase the amplitude. So as you can see here, you have your input. This is your sound wave input from your transducer. It has a very small amplitude, same frequency. Your output has a much higher, stronger signal and amplitude, but it remains the same frequency. The way transformer increase output voltage is basically, yeah, like I said before, it does that. And also, it can do all of this without causing any impedance. So it can increase your voltage, your output voltage, without causing any impedance. So output stage, so the most common type of output for these audio microphones is a 3-pin XLR connector. So basically the way this works is you have your first pin right here, that's your ground/shield. So it basically connects your circuit to ground, but what it also does is it stops any interference from any outside signals that may be passing through the general area. So it stops any signal interference, so you have only your sound wave electrical signal passing through without anything interfering. And then your second pin basically sends out a positive version of your AC signal, and your pin 3, your negative, sends a negative variation of your DC signal. So real world use, so I like using this example because they go hand in hand. It's a microphone and a speaker. So basically, what a speaker basically is a reverse microphone. So you have your mechanical energy gets picked up and gets turned into an your mechanical energy, your sound wave signal gets picked up through the microphone and gets turned into an electrical signal. And this electrical signal travels through your 3-pin XLR, gets outputted into the speaker, and your speaker takes your electrical signal and transforms it back into a sound wave, which is your mechanical energy. So here's a diagram. So you have your sensor stage. So your sensor stage is the sound wave itself. Your transducer stage, so this is your moving coil dynamic. So the sound signals get picked up and gets transformed into electrical signals. And you have your signal conditioning, which is your step-up transformer. So this takes your electrical signal that gets picked up through the transducer, and it amplifies it to a much stronger signal that's usable. And then your output stage is your much stronger output signal goes through your 3-pin XLR straight into whatever you're outputting it to, which can be a speaker, it could be your computer, so you could record it. It could be any electrical device that takes that type of output. So here's the actual specification. So here's your moving coil dynamic. It says type dynamic. That's just a short version of moving coil dynamic. Frequency response is between 50 and 15,000 hertz. The actual audio frequency response is between 20 and 20,000. That's your audible frequency. Polar pattern sensitivity have to do with the diaphragm and the way it moves. That's not really important, not the specifics. So polarity, basically what I explained earlier, positive pressure on the diaphragm produces a positive voltage. Connector type, your 3-pin XLR, as I already explained. And then you just have your dimensions and your weight right there. And that's it.